Hey guys, we have James here, CEO of Summa. He'll be talking about Bitcoin. I will let him take it from here.
And I'm gonna go ahead and make my webcam go away for a second because the lighting here is terrible. Let's focus on the slides. All right, there we go. My name is James Prestwich. I'm a co-founder at Summa, but like more importantly, I was recently voted best hair in Ethereum. So you might be wondering, like, why is this Ethereum guy coming here to talk about Bitcoin? The answer is that all of our work at Summa is actually about interoperability with other chains, with a special focus on Bitcoin. Currently, we work with Bitcoin, Ethereum, Celo, Near, Cosmos, and I'm sure I'm forgetting like a half dozen other people. So a lot of my time is spent working on open source Bitcoin tooling for other chains. You can find it on GitHub at Summa, the SummaTX org. There's the Bitcoin SPV repo, where we have 6 languages of Bitcoin SPV libraries. There's the Relays repo, where we have relays for Ethereum and Cosmos. And I want to talk a little bit about, what's going on in Bitcoin. It kind of stays under the radar. Most of the activity happens on the mailing list, and so it can be a little rough to keep in touch with new developments. So I want to start with just a crash course in Bitcoin, right? How does this thing work? A lot of people are going to be very familiar with Ethereum accounts and smart contracts, but less people are familiar with the UTXO system. So a Bitcoin transaction is actually a list of inputs. It's stuff we're spending, piles of coins that we're going to move around, and a list of outputs, which is the coins that are the new piles that we've arranged these coins into, right? So each input has a reference to the previous output. This is a typo, it should say output. And each output has a value and a pub key hash. This is the public key that can spend the output, right? So when you get a Bitcoin address, what it actually is a hash of a public key. So basically, it's just a list of inputs, a list of outputs, and the witnesses that authorize the spend. So for each input, there's one witness, which has the public key and the signature that authorizes it. This is kind of how it all fits together, is we have this previous transaction, which has some value and some pub key hash, and it's being referenced by the current transaction. And there may be many inputs in that transaction, and there's at least one output. So we take the whole transaction that we're creating, we put it through something called the SIG hash algorithm, and we sign that hash, right? And we put in a witness with the pub key and the signature. And when we're validating a transaction for each input, we're going to go into the witness and we're going to check that the pub key matches the hash from the previous output. And we're going to check that the signature matches the pub key and the SIG hash. And we're going to check that the transaction hashes to the SIG hash. So you have to do that once for each input, and it actually can get quite complex. There's a bunch of different steps, and a lot of my time is spent writing this and debugging it and figuring out how to evaluate it from other chains. And it's really kind of a mess sometimes. So I'm glossing over a lot of stuff here. This is a bit of a lie right here, right? There's not a pub key hash in each output. There's actually a hashed smart contract in each output. And so in the witness, there's a smart contract, which usually includes a pub key. And in the previous output, there's a hash smart contract, and we compare those, and then we evaluate the smart contract. These smart contracts are written in Bitcoin script. It's a very simple forth-based stack language. It's weird and nobody really likes it, but it is what Satoshi wrote, and we're really stuck with it at this point. There's no good reason for script to be what it is. And script kind of looks like this. This is what's called a hash time lock contract. So this is spendable by one pub key and if they know a secret, or by a different pub key after a certain amount of time. And so we can see the different pieces of that is this part is checking if you know the secret. This part's a pub key, this part's a pub key, and this part is checking if a timeout has elapsed. And those are the only things you can really do with Bitcoin script. You can check signatures under a certain key. You can check that some time has passed, or you can check that somebody knows a secret. You can do arbitrary recombinations of those things. So you can say, for example, Alice and Bob and after Tuesday, right? So all three of these things have to be true. You can do Boolean combinations. You can do arithmetic combinations as well. So you can say Alice's signature is worth 3 points and Bob's is worth 7, and you need 15 points to spend. But generally speaking, these things don't get used much in practice. Lightning being hash time lock contracts is generally the most complex script you're going to see in the wild. The reason is that unlike Ethereum, which has rich on-chain state, Bitcoin script is essentially a predicate on the transaction. The only thing it can do is read small parts of the transaction. And so you can't have dynamic programs. They have to be very simple, very static. So for example, you have to know that you're sending to Alice's public key. You have to know that public key in advance. Right. So now that we have the basics out of the way, let's talk about some recent off-chain development. This is generally going to be dev tooling to make using transactions and script easier. So, one of the things I'm really interested in is miniscript. This is a language for building script, and it looks kind of like this. You express those Boolean combinations very straightforwardly. So this is Alice's pub key and Bob's pub key. And you can do both of Alice and you can do Alice and one of Bob or time. So it's fairly straightforward to write mini scripts. So for an example, here's a script, and the script checks. This is a script used in Lightning, and it checks for one signature or some other signature or some hash secret. And it's expressed much more simply in miniscript. So you need one of these two conditions, the second condition being both of these two conditions. Let me make sure my mouse is visible. So you need one of these two, and this is one condition, right? So you need either the revocation key, or you need the key remote and either a secret and another key or a timeout. So you can express the exact same constraints. It's just much more legible and maintainable. Miniscript is essentially a compiled language. It compiles to script, and it's maintained by Peter Willa at Blockstream and a few other people. Peter Willa is going to come up a lot in this conversation. Okay, so one of the other things that I've been working on implementing lately is partially signed Bitcoin transactions. In order to sign a transaction, we talked about all this earlier. You need to know a lot of things. You need to know what the transaction is, what it's spending, the lock on what it's spending, the smart contract on what it's spending. You need to know the actual smart contract underlying that lock. You need to be able to check signatures, and in order to do that, you need to have keys, and you need to be able to produce signatures, which means you need to figure out which pub key goes with which priv key and whether you have that priv key and all of these fun things. And you need to know any other signatures on the transaction that might already exist. So really, there's just a bunch of information you need in order to sign a Bitcoin transaction. And you need all of this information for each input. So if you have 30 inputs to your transaction, you're going to need quite a lot of metadata. Partial PSBT is a data format for solving this problem. Basically, it's a standard way to encode a transaction and all the metadata anyone might need to sign it, and to be able to send that around from person to person and standardize across wallets. So it's seeing a lot of adoption in software and hardware wallets, but it's still like fairly early days. It's specified in BIP 174, I think, but don't hold me to that. Just go look it up. I have a work in progress Rust implementation that's going to be like a WASM browser library for doing this. And kind of on that note, we've been working a lot on browser tech for Bitcoin lately. I'd like to be able to use Bitcoin, as easily as you use dApps in Ethereum. So our recent proof of concept MetaMask signer is up on GitHub now. You can use this to sign Bitcoin transactions using your MetaMask wallet. The current version is not at all safe or secure. It's kind of a bad idea to use, but we expect a full version using the new MetaMask extension system around June. Okay, so kind of the state of off-chain Bitcoin development is that everything is focused around making script and transactions easier to build with. We're building bigger, better transaction abstraction layers, essentially. You have mini-script for making more complex scripts and for having something where a machine can recombine scripts easily. You have partially signed Bitcoin transactions, and you have a bunch of new wallet tech like MetaMask signers, like all the CoinJoin stuff in the Wasabi and Samurai wallets. So what's going on chain? Well, because this is Bitcoin, there's not a whole lot of new consensus changes. These things tend to move pretty slow. The last Bitcoin soft fork was in November or maybe October, somewhere in late 2017. So it's been 2.5 years since the last consensus change. We have two things coming up that I think are really exciting, but the timeline for them is unclear. So the first of those is called Check Template Verify. It used to be called Secure the Bag, and I like that name a lot better. So Check Template Verify adds a new kind of condition to script. Script can verify, that you have a private key, that some time has passed, or that you have knowledge of some secret. Check Template Verify adds a template system to this. So you can actually check that the spending transaction follows some template. You can place restrictions on what other people can do with this money. And those restrictions can carry forward through a pre-generated tree of transactions. So what Check Template Verify does is essentially allows you to do very complex multi-transaction smart contracts. So for example, this is a non-interactive payment channel. The way Lightning works right now is that if I want to send you money, I have to communicate with you. We have to agree on a shared hash, and then we have to exchange the pre-image to that hash. It's kind of weird and annoying, and we should be able to do that without communication. So what Check Template Verify enables is a non-interactive channel where we can both safely pay each other money while the other person is online. And it does this through multiple off-chain transactions that are verified by template rather than signature. It's a very interesting and powerful tool. And I can't overstate enough how cool and interesting it is. But again, this is Bitcoin. Development happens very slowly, and Check Template Verify is in kind of BIP limbo. it's unclear when, if ever, this will be going into Bitcoin. Check Template Verify is Jeremy Rubin's brainchild, and he's the main person pushing it. And if you're interested in getting involved in Bitcoin development, this would be a great place to start. For a few more details about what a template is in this system. Normally in a Bitcoin transaction, you can only look at the script. So you can only look at these things with red arrows here. And you can only do it in very limited ways. So a script, for example, can't know the value of its UTXO that it's authorizing except very indirectly. The signature has to sign that value, but the script can't load it onto the stack and operate on it. With Check Template Verify, you can have a transaction template that says that the output values of the next transaction must be exactly the same as the output value of this transaction, or other complex constraints like that. So instead of just checking that there are signatures, you can make complex rules on what transactions can spend from this script. Okay. I know that I haven't explained that super well. You should really go read the BIP because it's very complex. There's really no 5-minute explanation of that I can give. So I want to move on to kind of the last thing we're going to be talking about, and then I'll go more into questions and discussion. So a couple, I want to say years back, Greg Maxwell posted to the mailing list with a cool idea for hiding scripts. The way Bitcoin works is you post a script hash to the chain, and then later you have to show the script that hashes to that, and that script is run. Taproot is a way that you can sometimes avoid showing the scripts. You can kind of embed them into a public key. And then you only have to show the script if something goes wrong. So it allows you to shortcut scripts that go cooperatively. So for example, the way a Lightning transaction works is that you and I enter into a contract, and then we update it cooperatively. And there's a fallback if either of us tries to cheat. The hash time lock contract goes on chain, and the person who didn't cheat gets all the money. But in the happy case, where we just cooperate and then we want to close out the channel, that HTLC never goes on chain. What goes on chain is just a multi-sig transaction. And so it's very straightforward and simple. The happy case is just we both sign the transaction. The way Taproot works is basically the same, is in the happy case, the transaction just gets a signature. But the script is still there, waiting in case anything goes wrong. So Taproot is going to be a really cool thing. It also enables trees of script and much larger scripts in general. Again, I don't want to get into too much of the technical details because it ends up very complex. The main new thing that's being added with TapScript is Schnorr signatures. We're moving out of the SecP-based ECDSA and into Schnorr. And the way scripts are hidden in Taproot is actually as a linear offset to the Schnorr pub key, which we can only do because it's Schnorr, and you can't do effectively in ECDSA. Okay, so what else is going on? We've talked about off-chain development. We've talked about on-chain development. What am I not covering in depth during this talk? There's a lot more usability and dev tooling work around output descriptors. Vaults and pre-signed covenants are closely related to Check Template Verify, its way of doing large, complex, multi-transaction protocols. I haven't talked about Lightning at all during this talk, but there's a lot of cool stuff going on with it. They just pushed atomic multipath payments. So your Lightning payment can now take many different paths all at the same time. There's a new Bitcoin testnet called Signet coming out. This is essentially a proof of authority Bitcoin. The mining pool protocol Stratum is being upgraded. And so you will see a lot of like changes to the way mining pools function in the future. The goals of Stratum v2 are to essentially allow the individual miners to pool together without allowing the pool to have strong constraints on block construction the way it does now. So this is really cool and is being pushed by Matt Corallo over at Square Crypto and a few other people. And one of the things that we're working on along with Keep is TBTC. So some people have been talking about this in chat already with, I don't even know, I don't read chat. But TBTC is coming out in a week or so and will be a tokenized Bitcoin on Ethereum. So we're really excited about that. It's a nice chance to see a lot of the code we wrote out in the wild being used by other people to produce something cool. All right. So if you want to learn more about this, I would strongly recommend the Bitcoin mailing list, the Lightning mailing list, the Socratic seminars, which are hosted by BitDevs SF and BitDevs NYC. I believe those are online meetups these days, so they're really easier to attend than ever. There's the Bitcoin OpTech mailing list newsletter, which will cover a lot of the things like output descriptors, PSBT, mini scripts, etc. And hang out on Twitter and ask people questions. There's a bunch of Bitcoin devs there, and they're all like, well, the developers are very friendly. The rest of the like Bitcoiners on Twitter, not so much. All right, we have about 5 minutes left on my time, so I'm going to go through the questions here. So the first question is, do I see a convergence between Bitcoin and Ether, or will the two remain in separate camps for the foreseeable future? You know, a lot of like my personal work is about interoperability. So I don't see like a convergence between Bitcoin and Ether. What I do see is a growing group of smart engineers who are nonpartisan, who aren't like maximalist in one camp or the other, and just want to build good tech and do cool things. And a lot of like my coworkers, my friends, and I are in this camp. I don't see this as a convergence of Bitcoin and Ether. I see this as a like group of people who are just trying to get cool work done. Okay, next question is, in 2020, how many people would you consider contributing to the core of Bitcoin or having a significant vote in the community? How decentralized is core contribution to Bitcoin code? This is actually a really interesting question. Bitcoin Core has tons and tons of contributors, and PR updates to tests and documentation are going in from a bunch of different people all the time. You can go check out the GitHub and look at the commit history and see that it's actually growing over time. I think this is a really interesting contrast to like Bitcoin, which is primarily maintained by the Purse team, BTCD, which is primarily maintained by the Lightning and Decred teams, and Geth, which is maintained by the Foundation, and Parity, which is going through a weird maintenance transition right now. Out of all the major clients for a blockchain, Bitcoin Core has the most contributors, and it seems to be getting easier to contribute. There is an incredibly high standard of review for consensus code, but it is like fairly easy to dive in, make PRs, do documentation and testing and usability and scaffolding improvements to Bitcoin Core. There is a whole like group run by John Newberry over Chain Code that does PR reviews for Bitcoin Core. There's a guide on how to make your first core PR, what's easy to work on, how you should go about identifying it, who you should talk to. I'm actually really excited for how decentralized core contribution to Bitcoin is. Let's see. So Drew asks, Bitcoin's conservatism makes for great security and makes it a good store of value. Ethereum's willingness to move faster makes it a better development platform. How do you see the economic bandwidth of Bitcoin coming to the Ethereum network? Any thoughts on proof of transfer? I don't have any thoughts on proof of transfer. I do work on things, a lot of interoperability projects with different chains that are, trying to bring Bitcoin or, a reasonable Bitcoin substitute to other chains. There's an increasing amount of work in this space from companies like Interlay, who's working on the Polkadot bridge. Nomic is, there's 3 companies called Nomic, and one of them is working on Bitcoin on Cosmos. They're based out of SF. There's Keep working on TBTC. We've been working with Summa, Keep, and several other companies on a nonprofit called CrossChain Group to kind of standardize a bunch of these development processes. To answer the question of how do I see it, it's a long, slow process. We've been working on TBTC and related things for close to 2 years. So it's really a thing of it just needs work, it needs time, it needs engineers. Cool. I think that just about wraps it up for me. This was really fun. I hope, if you have any questions about stuff or how to get involved, go ahead and reach out over Twitter. I'm going to be posting these slides somewhere in the future, and when I do, I'll post a link on my Twitter.
All right, thanks, James. This was a really great talk. Really appreciate your time. So now we're going to transition to the next session.